students, I hope your preparation is going good. If not, don't worry. Sri Gurukula is here to help you. And I am Anmol Yadav. I will be your physics and mathematics mentor. I am an NEET graduate. So bring out your books. Let's make your preparation stress-free. Today I am back with another video to help you prepare for your competitive exams. Today we will be studying motion in a plane, and aim of this video is to quickly revise the important concepts on which they can ask questions, and we will try to solve some few PYQ questions as well. So let's start with it. We'll start with motion in plane, or also known as motion in a two-dimension, 2D, correct? So now, before that we have studied motion in a one dimension, that is motion in a straight line. Now the object is moving in two dimension, x dimension and y dimension. So let's suppose object is moving like this. Okay, so this is the initial velocity, initial point. Initial velocity is u vector, and this is the final point, and the final velocity will be v vector. So if everything is given in a vector form, for example I cap, j cap, then we will use all these three formulas, motion formulas, that is v vector is equals to u vector plus a vector t. If everything is given in vector form, we can use these three formulas. S vector, displacement vector, is equals to u vector into t plus half a vector into t square, and another v square minus u square. V square minus u square is equals to 2 a vector dot s vector. Right? So these three formula we will use if in the question everything is given in the form of vector, that is I cap or j cap form, correct? So this is the process. Now there is another way to understand this motion in two dimension. So actually the best way to study motion in a two dimension is to divide this two dimension into study of one dimension problem. One dimensional problem, that is we will divide this study into two dimension, that is we will study in x direction, we will study in y direction, and finally we will find the resultant of both the x direction and y direction. So how we will do that? For example, let's see, this is the path the body is traveling. At any point, let's suppose it has a velocity v, correct? It has a velocity in this direction, and let's suppose this direction is at an angle theta from x-axis, correct? So now we know how to do components of vector. So if this is v, this will be v cos theta, and this will be v sin theta, correct? So we have divided the velocity in two components. Now velocity in x direction, this is our x-axis, this is our y-axis. So velocity in x direction is v cos theta, v cos theta. This is velocity at any time t, and similarly velocity in y direction is equals to v sin theta, correct? Now what will be the resultant? Now we divided into two dimensions. Now we will do all our studies, and finally we will do the resultant. How will we do the resultant? So see, if we'll square on both the side, and if we'll add this to equation after squaring, for example vx square plus vy square, we did square on both the side and we are adding the equation. Similarly, it will be equals to v square cos square theta plus v square sin square theta. So what I did square on both the side of these two equations, and I added these two equations. Now I can take v square common here. So vx square plus vy square is equals to v square into sin square theta plus cos square theta will be equals to 1. So velocity will be equals to root of velocity in x direction square plus velocity in y direction square, correct? Similarly we will do for acceleration as well. Acceleration at any point will be acceleration in x dimension square plus acceleration in y direction square, correct? Now if this is final velocity, okay, if initial velocity is u in some direction, let's suppose this is u, so again we will do components. This will be u in x direction, this will be u in y direction, and this is velocity in x direction, this is velocity in y direction. Now again in two directions, these two directions we can still apply all the formulas from motion in a straight line. That is, I can write velocity in x direction is equals to dx by dt. Velocity in x direction is displacement in x direction divided by change in time. And similarly, acceleration in x direction will be equals to change in velocity in x direction divided by dt. Correct? Or another formula will be velocity in x direction into change in velocity in x direction divided by dx, change in displacement. Correct? These are the formulas that we have studied in motion in a straight line. Similar things will apply in y direction as well. So Vy will be equals to dy by dt, displacement in y direction divided by dt, and acceleration in y direction will be equals to dvy by dt is equals to vy dvy by dy. Correct? So these are the same formulas that we have studied in motion in straight line. What we are doing, we are just applying in two different dimensions. These formulas all are written in x directions, and this all formulas are applicable in y directions. So this formulas will use when acceleration is not constant. But when acceleration is constant, we know we have derived three formulas. So after solving this, we'll again get three formulas, that is velocity in x direction will be equals to initial velocity in x direction. This is final velocity in x direction is equals to initial velocity in x direction plus acceleration in x direction into t. Displacement in x direction is equals to initial velocity in x direction into t plus half ax t square, and vx square minus ux square is equals to 2ax sx. Correct? Similarly, we can find in y direction as well. So velocity in y direction will be equals to initial velocity in y direction plus acceleration in y direction into time. Displacement in y direction will be equals to uyt plus half ay t square, and final velocity in y direction square minus initial velocity in y direction square is equals to 2 times ay sy. So this is nothing but all those these are the same formulas that we were using in motion in a straight line. Just what we are doing, again we are applying in straight line but in two different dimensions. This is in x direction, this is in y direction, and after solving everything like this, finally we will, if they are asking for final velocity, what we will do, we will use this formula. We will find vx, we will find vy, and we will use this formula to find the velocity. Similarly, we will find ax, ay, we will use this formula to find the acceleration. So this is the concept, or this is how we are supposed to solve each and every question in our motion in a plane. So if you know this concept properly, you don't need to study actually anything else in this chapter. You can solve each and every question just by these concepts only. Now further we derive so many formulas in projectile, horizontal projectile. Those formulas we are remembering just to solve questions quickly. But still, if you don't remember those formulas, you know this concept, you can actually solve each and every question 100% sure. Understood? Now let's see few questions. First question is, if x and y coordinate of a particle at any time r, x is equals to 5t minus 2t square and y is equals to 10t respectively, where x and y are in meters and t is in seconds, acceleration of the particle at t is equals to 2 seconds. Now we have a displacement in x direction, we have displacement in y direction. So again we will divide the study in two dimensions. We will study in x direction, we will study in y direction, and we will do the resultant finally. So now we are supposed to find acceleration. So we know that acceleration in x direction will be equals to dvx by dt, and velocity in x direction is equals to dx by dt. So this dx by dt I will put here. So acceleration in x direction is equals to d2x by dt square. Similarly, acceleration in y direction will be equals to d2y by dt square. So we will double differentiate this equation, and finally acceleration. See, we have acceleration in x direction, acceleration in y direction. What will be the resultant? Root of ax square plus ay square. So now one by one we will find ax and ay. So we will differentiate this 2 times. So first we will find dx by dt. So dx by dt is differentiation of this, it will become 5 minus 4t and we'll differentiate it again to find ax. So differentiation of this will become -4. So this is our acceleration in x direction, and we'll differentiate this again. So dy by dt will be equals to 10, and if we'll differentiate this again, differentiation of constant will become 0, means acceleration in y direction is equals to 0. Now we have ax, ay, we will use this formula. So a will become root of -4 whole square plus -4 whole square plus 0. So a is equals to root of -4 whole square, which is equals to -4 meters per second. Any answer? Yes, B option is the correct answer. Correct. Now let's see another question, another easy question. So a particle have initial velocity as 2i cap plus 3j cap and acceleration 0.3i cap plus 0.2j cap. The magnitude of the velocity after 10 seconds will be. So I said you, whenever they have given velocities and acceleration, everything in the vector form, we will use the equations, all these three equations in the vector form. Now they have asked the final velocity. So we know that final velocity in vector form is equals to initial velocity in vector form plus acceleration in vector form into time. Correct? So final velocity in vector form, it will be equals to initial velocity, it is 2i cap plus 3j cap plus acceleration is 0.3i cap plus 0.2j cap into time, and time is 10 seconds. After 10 seconds we need velocity. Now if we will multiply this 10 inside, it will become 2i cap plus 3j cap plus 0.3 into 10 will become 3i cap, 0.2 into 10 will become 2j cap. So final velocity vector is equals to 2 plus 3 5i cap, 3 plus 2 5j cap. Now resultant vector magnitude will be equals to root of 5 square plus 5 square, which is equals to 5 root 2 meters per second. Any option? 5 root 2 meter per second. Option B is our correct option. Now another easy question. A person aiming to reach exactly opposite point on the bank of a stream is swimming with a speed of 0.5 meter per second at an angle of 120 degree with the direction of the flow of water. The speed of the water in the stream is. So let's try to understand the question. So let's suppose water in the river is going in this direction. This is our velocity of river. Correct? Now a person is trying to reach exactly opposite side of the river. So initially he is here, he is trying to reach exactly opposite side. Correct? If you make a vertical line, he wants to reach from point A to point B, and the swimmer is swimming with the speed of 0.5 meter per second in the direction 120 degree with the direction of flow of water. So this is let's suppose this x direction is the direction in which water is flowing. Now with this direction, the swimmer is at a 120 degree angle, means 120 degree angle. So this is like 0.5 meter per second at an angle of 120 degrees. Now quickly we can solve this question. How? I said you, whenever you are seeing question in 2 dimension, try to divide it into motion in the 1 dimension. So what we'll do the components first. So if we are seeing velocity at some angle, we'll find the x component, we'll find the y component. So if this is 120, this will be equals to 60 degree. Correct? So 0.5, this is velocity. Let's suppose this is velocity of men is equals to 0.5. So velocity of men at an angle of 60 degrees. So this component, x component, will be equals to velocity of men cos theta, and this component will be equals to velocity of men sin theta. Now if he wants to reach exactly opposite side, means this velocity in this direction should be 0. That means the net velocity that he is having should be in only upward direction, but he has the velocity in x direction. So we need something to balance this velocity. So men is moving in this direction and this direction. So Vm cos theta and cos 60, Vm is equals to 0.5, which is 1 by 2, and cos 60 is also 1 by 2. Correct? And this is Vm is 1 by 2 and sine 60. Sine 60 will be equals to root 3 by 2. Correct? So Vm, so in this direction, the velocity is root 3 by 4. In this direction, the velocity is 1 by 2 into 1 by 2, which is 1 by 4. But the net velocity should only be in this direction. So we need some extra velocity to cancel out this velocity. And who will give that velocity? This river. So we need Vr, correct? Now the net velocity should be vertical, means these two velocities should be equal, they should cancel out each other, means velocity of river should be equals to 1 by 4 meter per second. Then only the swimmer will be having only velocity in this direction and it can reach directly to the opposite side. So velocity of river will be equals to 1 by 4 meter per second and the correct answer will be option A. Now there are so many questions. See, they ask so many questions every year. So in the competitive, in the board, how it is like, there is some pattern. Some questions they will repeat so many times. But competitive is not like that. They will try to create new type of questions. So there is one concept on which they have never asked a question, but they can ask a question. What is the concept? The path length. Path length means a body is moving in 2 dimensions like this, correct? So they will ask from point A to point B. We can only find, using those formulas, we can find the displacement, velocity and acceleration, which is only depending on initial position and final position. But what if they are asking what is this path length? What is the distance that body is traveling on this path? So distance we can't find using those formulas. So how we will do? So to calculate the path length, let's suppose the path length is L. Path length is L. So how we will solve? We will try to calculate this small displacement. Like from A, I am going at some x distance. From A, I am going to some x distance, and I am finding a dx component. Make it something like this. From A, I am going to x distance, and I am taking a component of dx. Means, and this is our small dl length. So if I will zoom it out, so this is our dl length, small dl means small path length. In this path, it is a straight line. Means here, displacement for a very small dimension, if you are doing it very small, if you are seeing it at a very small scale, then this is not a curved line. At very small scale, it is also a straight line. And at what we are seeing? We are seeing for this dx length. When a particle is moving from x to x plus dx, means this length, it means it has moved in y direction as well, some dy length. It means it has moved in y direction because the particle is moving in both directions. So if I am taking some small displacement in x direction, I will have to consider some small displacement in y direction as well, because particle is not moving in only one direction, it is moving in 2 directions. Now, since x-axis and y-axis are perpendicular to each other, means dx and dy are also perpendicular to each other, means this angle is 90 degree. And now you can see a triangle, right angle triangle and 3 lengths. Which formula I can use? Pythagoras theorem. Means dl square, dl the whole square is equals to dx square plus dy square. Now what I will do, this dl square, I am taking dx square as common. So this will become 1 plus dy by dx, dy square by dx square into dx square. Why I did like this? These two are the same thing, right? If I will multiply this dx square inside, you will find the same thing again. See, dx square into 1 will become dx square into dy square by dx square. So this 2 will cancel out and the only term we are left with dy square. Now I will take root on both the sides. This will become dl, root of this will become dl is equals to root of this entire term, which is 1 plus dy by dx whole square, and this root of dx square will become dx. Now if we will integrate this, see limits on x. So from x we are going from x at point A to some point B, x at point B. So limits on x will be from xa to xb, limits on L from A to B, and this is actually our path length. Path length. This is how we'll calculate the path length. We will find the slope at any point plus 1 the whole square plus 1 under root, and we'll integrate with dx, and you will find your path length. This is the concept they have never asked question on, but they can ask question from this concept as well. So make sure you practice this. Okay, so this is what for this video. In the next video we will try to solve, we'll see the concepts of projectile, horizontal projectile and projectile at an angle theta, and we'll try to solve some PYQs on that as well. So stay tuned for the video. I will be back soon. Till then, keep practicing. This is Anmol Yadav from Sri Gurukula signing off.